All right, welcome back. In this lecture, I am going to cover pedigrees. And so in Google Classroom, there is this pedigree life science assignment, and I think it does a great job introducing pedigrees, and so we are going to do it together, and then you're going to get a different pedigree assignment. So first off, what is a pedigree? So I'm going to zoom in here so you can see this a little bit better. A pedigree is a visual chart that depicts a family history or the transmission of a specific trait. They can be interesting to view and can be important tools in determining patterns of inheritance of a specific traits. Pedigrees are used primarily by genetic counselors when helping couples decide to have children when there's evidence of a genetically inherited disorder in one or both families. They are also used when trying to determine the predisposition of someone to carry a hereditary disease, for example, familial breast cancer. And so this is a pedigree. It's like a family tree. And it's made up of shapes, circles, and squares. And a circle represents a female, and a square represents male. And if the lines are connected to each other like so, that usually indicates marriage or that they had children together. Vertical lines connect the parents to the children. And so you can see that this couple had 3 kids. If I follow the lines, 1, 2, 3. And we can tell how many boys and girls they had. They had 1 son and 2 daughters. And then you can see that because there's a line connected here, maybe that they, got married or they just had kids. And so this son had 2 girls with this woman, and so 2 girls over here. This daughter has no children, and this daughter married or had children with this man, and they had 3 children, 2 sons and a girl. So that's the lines and the shapes. Now you may have noticed that some individuals are shaded in. And so in this pedigree, they are looking at the trait called the white forelock trait. And if you are shaded in blue, then you have the white forelock. And that just means kind of a white spot somewhere in the hair. Sometimes it's in the front, sometimes it's in the back, but it's just a spot where all the hairs are a little bit white. And believe it or not, it is a hereditary trait that gets passed from generation to generation. Individuals that are not shaded blue do not have the white forelock trait. So, components of a pedigree: squares indicate males in a family, circles indicate females. If it's darkened or shaded in, that means that they have that trait. That means the individual is affected by that trait. A line between male and female indicates marriage or union, and the line drawn from the marriage line indicates offspring. Sometimes you will see some shapes filled in halfway, like so. This notation indicates a hybrid. That means they have the capital letter and the lowercase letter. They are a carrier of the trait. All right, moving on to the second page. Analyzing simple pedigrees. A pedigree is just like a family tree, except that it focuses on a specific genetic trait. A pedigree usually only shows the phenotype of each family member. With a little thought and the hints below, you may be able to determine the genotype of each family member as well. Hints for analyzing pedigrees. If the individual is homozygous recessive, okay? Homozygous recessive. Homozygous means the letters are the same size, and then this keyword recessive means that they are both lowercase. Then both parents must have at least 1 recessive allele. Parents are heterozygous or homozygous recessive. If an individual shows the dominant trait, then at least one of the parents must have the dominant phenotype. This one will be pretty obvious when you look at the pedigree. If both parents are homozygous recessive, then all offspring will be homozygous recessive. Note: in a pedigree, the trait of interest can be dominant or recessive. The majority of harmful genetic conditions are only seen when an individual is homozygous recessive. Examples of conditions caused by recessive alleles include cystic fibrosis, a disease of the secretory glands, including those that make mucus and sweat; Fanconi anemia, a blood disorder; albinism, a lack of pigmentation; and phenylketonuria, not sure if I said that right, a metabolic disorder. Some genetic conditions are caused by dominant alleles and may therefore be expressed in homozygous dominant or heterozygous individuals. Examples of conditions caused by dominant alleles include polydactyly, the presence of extra fingers; achondroplasia, a type of dwarfism; neurofibromatosis, a nervous disorder; and a disease known as familial hypercholesterolemia, in which affected individuals suffer from heart disease due to abnormally high cholesterol levels. If you have read this far, we applaud you. Okay, so let's take a look at this page right here at the bottom part, human pedigrees, and let's do it together. So I copied and pasted it so that I could write on it. Okay, so it says for questions 1 through 9, use the pedigree chart shown below. Some of the labels A through D may be used more than once. All right, which letter indicates a male? Okay, so remember pedigrees, males are going to be square. So I look, all right, in this case, it's going to be C. All right, females are circles. So that would be A. Which letter indicates marriage or union? That would be B. You can see this line connecting between the circle and the square. A person who expresses the trait is a shape that's filled in, and so in this case that will be A. A person who does not express the trait, that would be C. A connection between parents and offspring, that would be D. How many generations are shown in the chart? So generations are like levels. How many layers are there? So we have 1, 2, 3. So there are 3 generations shown here. So that means that, let's just say that like you're one of these squares, okay, or one of these shapes. These would be your parents, and these would be your grandparents. Assume in the chart above is tracing the dominant trait of white forelock, denoted by a capital F, through the family. F is a tuft of white hair on the forehead. What is the most likely genotype, so genotype's the letters, of individual A? All right, so this pedigree is showing the dominant traits. So all these individuals that are shaded in have the dominant trait, which is a capital F, okay? So I know for sure that A has a capital F because they are shaded in. Now I need to take a look at the children. Okay, so there are some individuals that don't have it and there are some that do. And so this person has the trait, they have a capital F, this person doesn't. So everyone that's not filled in is actually a lowercase f. Well, if I have a child that does not have it, that means that they are little f too, right? So dad doesn't have it, mom does, this daughter doesn't have it. Well, remember with Gregor Mendel and his factors, you get one factor from each parent. So this little f came from dad. Where did this little f come from? Well, it had to have come from mom. And so mom is actually, she has the trait, but she carries the allele for no white forelock. So A is actually capital F, lowercase f. Okay, right here. What is the most likely genotype of individual C? All right, so they don't have it. Okay, so that means that they are homozygous recessive, and they're going to be little f. So I'm just going to circle because right in my little L. I guess I should write my little f's. Okay. Continuing on. Example 1. Tracing the path of an autosomal recessive trait. Trait Fanconi anemia. Okay, so autosomal recessive means that this trait shows up when it's a recessive trait. The only way you can have Fanconi anemia is if you have 2 lowercase letters, and we are going to follow the path of it. So the dominant form is normal, bone marrow function, no anemia. The recessive form is Fanconi anemia. Individuals affected show slow growth, heart defects, and possible bone marrow failure, and a high rate of leukemia. Here's the pedigree below. So I think I copied and pasted this onto my next slide. There it is. Okay. Note that carriers are not indicated with half-colored shapes in this chart. All right, so that means individuals that are shaded in, okay, have it. So Arlene is shaded in. She's little f. They did that for Carla. Wilma, she's shaded in. She's little f. So that would be like the first thing I would do in a pedigree is just, if you know one of the genotypes, go ahead and write it in. All right. So all the shaded individuals are little f. Okay. All right. What is Arlene's genotype? So Arlene has it, and if you're shaded in, that means you're going to be little f, little f. So Arlene's genotype is little f, little f. What is George's genotype? Okay, so George doesn't have it, right? So you know for sure he's got the big F. But let's just see if they have any kids that have it. Oh, geez, Tom and Wilma have it. Let's just look at Wilma. Wilma got one of the little F's from Arlene. Where did she get the other little F? She got it from George. So George is actually a carrier for it, okay? So George is going to be big F, little f. What are Anne and Michael's genotypes? All right, so here's Anne and Michael, and they had a daughter, Carla. All right, so they don't have it, so they for sure have a big F. Okay, but Carla has it. And again, Gregor Mendel says you get one factor from each parent. So Carla got the little f's from both Anne and Michael. So that means both Anne and Michael are big F, little f. So big F, little f. Sandra, most likely Sandra's genotype is, all right, where's Sandra? Ah, there she is. Okay, so Sandra and Tom had 2 sons. Daniel for sure is big F, little f. Alan, you know for sure he has a big F. We don't know, well, big F, and he's probably got the little f from Tom because that's the only thing Tom can give to his kids. So Sandra, she doesn't have it. There's a good chance that Sandra is big F, because both of her kids don't have it. If one of these kids did, and you know she was a carrier for little f, so her most likely genotype would be 2 big Fs. List 3 people from the chart, other than George, who are most likely carriers of Fanconi anemia. So carriers means you're going to be big F, little f, okay? So you can write down Anne and Michael and Alan and Sam, Daniel, excuse me. So lots of people that you could list for big F, little f. All right, one more pedigree. Tracing the path of autosomal dominant trait, neurofibromatosis. The dominant form in neurofibromatosis caused by the production of an abnormal form of the protein neurofibromin. Affected individuals show spots of abnormal skin pigmentation and non-cancerous tumors that can interfere with the nervous system and cause blindness. Some tumors can convert to a cancerous form. The recessive form is a normal protein, in other words, no neurofibromatosis. A typical pedigree for a family that carries neurofibromatosis is shown below. Note that carriers are not indicated with half-colored shapes in the chart. Use the letter N to indicate the dominant neurofibromatosis allele, and the letter N for the abnormal allele. Okay, so this is a disease that's caused by the dominant form. Okay, so individuals that are shaded in purple for sure have a capital N. So I'm just going to go ahead and write capital N for those colored in individuals. Okay. Now, if you are uncolored, okay, you're not shaded in, then your genotype for sure is going to be 2 little n's. So I'm just going to go ahead and write it in because you might as well be a detective and just figure it out. Okay. All right. Is individual 1 most likely homozygous dominant or heterozygous? Okay, so we got to take a look at 1 here. It's a mother. She marries this husband who doesn't have it, and they have 5 kids. 1, 2, 3, 4, 5. And we see some kids don't have it at all. Okay, so they're little n, and some kids do. So let's just take a look at a kid that doesn't have it. Okay, little n. Well, one of them had to have come from dad. Where does the other little n come from? Mom. Okay, so she's got both alleles, a capital letter and a lowercase letter, and we describe that as homozygous, right? Sorry, heterozygous, right? So she is heterozygous. And then it says, hey, how can you tell? Because she has kids that do not have a big N. Okay? So you have to explain why. What is the genotype of individual 3? So here's 1, here's 2, here's 3. Okay, hey, we did that in the beginning, right? So individual 3 is 2 little n's. Can you be sure of the genotypes of the affected siblings of individual 3? Can we be sure? Okay, so we know this person's big N. We know this person also has a big N, but they give us a little n. So if we take a look at, this girl and this boy, we know they have a big N, but can we tell what their second allele is? I mean, we don't know this person's genotype. So actually, no, you can't. No. You just know that they have a big N, okay? You don't know if they're heterozygous or homozygous dominant. So, all right, so that's pedigrees. So in your notes, it's just a little slide here, just one slide of pedigrees. Pedigrees are another way to show how traits are inherited. It's a diagram of family relationships. They show or help show the pattern of inheritance. In this one, we're looking at dimples. Blue is denoted by a capital B. Red means that they have no dimples at all. And you can see just how individuals are affected in this generation. Okay, so your assignment is to do the pedigree assignment and, see if you can be a detective and figure out how traits, what are the genotypes of some individuals and whatnot.